and gentlemen, welcome to the 2021 Day 5 Connect Conference, brought to you by Huawei and IoT and Engine Stream partner, Software AG. Enjoy the next session.
Good morning, everyone, and welcome to the next session in the Connect Conference on the IoT stream. We're very fortunate to be joined by a phenomenal speaker this morning, Mr. Peter Reid. Welcome, Peter. I'm just going to do a brief introduction. Peter heads up a company called Mint Intelligent Insights. It's an AI business that specializes in computer vision. Peter Reid started in the Microsoft ECM space about 19 years ago at Innovate, which at the time was a small startup focused on intranets and websites. He has worked in the past as a developer, a consultant, and an architect before taking over the reins as CEO of Innovate in the beginning of 2016. And of course, with artificial being a massive interest for him, when the opportunity presented itself to start a practice within Mint, which was focused exclusively on artificial intelligence, he grabbed it with both hands. So some lesser known information about Peter is that his hobbies include deep cave scuba diving, something which I am absolutely petrified of. So I'm glad that he can go and get us the visuals and come and share that with us. And he's been fortunate enough to be a part of the women's deep diving world record set in March 2021. Congratulations on that, Peter. And then, of course, he's a marathon loving, running person as well, and he sent craft beer by random strangers. None of this is really peculiar, but then you do have a deep love for artificial intelligence. I'm going to hand over to you, Peter. Thank you very much for joining us today and sharing some of your interest and your sector expertise with us. We're very fortunate to have you, and thanks for giving up some of your time.
Anita, and thank you for the opportunity. So I'm just going to launch my presentation and we'll get started. So again, welcome. My name is Peter Reid. I run a business called Mint Intelligent Insights. And Intelligent Insights is a business that is focused almost exclusively on computer vision. Computer vision obviously being one of the pillars of artificial intelligence that's really come to the fore in the last while. And we do projects ranging from identifying whether your oranges on a conveyor belt have spots or not, to face recognition projects, to projects that would recognize what make and model of a car just had an accident outside your house. So really a fascinating area to play in. And what got me into the kind of passion of AI and computer vision was really this statement that I love from Arthur C. Clarke. To me, the AI world at the moment sometimes presents use cases to us that really look like magic. And considering where computers themselves have come from in the last while, where things have gotten faster and better and quicker, but really we haven't seen massive innovation across the board until artificial intelligence came past again, which is really one of the reasons that I love it so much. So how does AI and IoT work together? Well, we're going to dive into that a little bit. I was told a little while ago that I was in the IoT business, which came as quite a surprise to me until you consider how things like cameras, for example, are actually IoT devices. So I want to step a little bit into AI. Why is AI coming to the fore right now? Some of the trends in terms of moving to the cloud, cloud processing and cloud computing, really one of the massive trends that's driving the world at the moment. And then we're going to talk about AI and IoT and some examples. And then a quick discussion on privacy, because no talk on AI and IoT would be complete without talking about privacy. And then we'll just have a look at how we wrap up all of that. So really what we're going to be looking at is just what are the emerging trends in AI and IoT at the moment, mostly confined to computer vision and camera processing, and how are they going to affect the world that we live in now and in the next couple of years. So briefly, just why is AI suddenly becoming such a phenomenon? I interact with a lot of people who say that AI is a new technology, that the fact that AI has really risen to the fore in the last 5 to 10 years is driving a lot of circumstance around us. And while largely I agree, actually the roots of AI go back a very long time ago. So I thought I would just clarify quickly. If we have a look at probably what is considered the first rise of true deep learning, which happened in 2012, and it was when a neural network called AlexNet formed a stepwise jump in an ImageNet classification competition. Really jumped from your sort of 60% accuracies all the way up to 80s, and started performing better than traditional algorithms. But if we wind the clock all the way back, to me, neural networks, the core of AI, were invented in 1957. Between 43 and 57, they started rising and coming to the fore. It was when this concept of fuzzy logic started being worked on. But that invention of the perceptron in 1957 was the culmination of a couple of years of research. And the perceptron is a single unit inside a neural network. Now, these days, they have billions of these units. But the idea behind the processing really came from that 1943 to 1957 work. So really, AI has been around for a hell of a long time. And in fact, it's been a computational method that was just used alongside other computational methods for a little while. So why now? Why all of a sudden is AI embedded in every piece of technology that we might own? There's three things that we believe really gave rise to the kind of growth that we're seeing in AI. First and foremost is the cloud computing. Cloud computing has enabled the training of neural networks where before you might have to invest in very serious hardware. So perhaps a couple of servers with tens of GPUs running on top of them, or go down to the local IBM mainframe and book some time on it. Cloud computing really allows you to click and spin up a virtual machine, run a neural network for an hour's training, shut it down, and you've paid only for that hour. So really made a significant dent in the cost and therefore time to market of artificial intelligence. The second factor on the bottom right there you'll see is the rise of large-scale label database sets. So starting in 2012 with AlexNet, excuse me, all of the modern applications of AI use readily available large-scale databases, not just in the image space, obviously in sound, for voice transcription, for translation in language, but having access to millions and millions and millions of sound bites or images is really the second key thing that's grown. And actually that was also driven by the cloud. But if we think about a very specific area like face recognition, training face recognition models was very, very hard until platforms like Facebook, LinkedIn, etc. came along, where you could get access to millions of images to train on. Obviously, there's a lot of privacy concerns there. Excuse me. But really, these databases are what caused the revolution. And then the third thing is I would say the convention or agreement on standards. So I've got an image there of TensorFlow, but really before standardization, there were lots of different types of neural networks. There were lots of different formats. And if you wanted to train one, you really had to be a specialist Python programmer and know a lot about mathematics and write your own perceptrons. So the rise of platforms that allowed you to build any kind of neural network on top of an existing architectural structure is what gave rise to AI as we see it today. And that's really come a hell of a long way, to the point now where it's embedded in everything that we look at. So I just wanted to give a few examples of some spectacular AI, and I thought, let me jump right into one that really seemed sufficiently advanced to be indistinguishable from magic. So this is a caption of a review on Amazon, and this caption was actually written by a neural network. Now, what's significant about this is that a group of professors commissioned a study where they did double-blind tests on captions that were written by human beings versus captions that were written by the artificial intelligence, the neural network. And really the conclusion that came out of that was there is no way of telling. It is actually impossible to tell whether a caption was written by a neural network or by a human being. Now, that's a really scary thought. A lot of nefarious uses that this technology can be put to, but actually it moves us into the realm of what we call human equivalent AI, or superhuman AI, where AI is performing above the level that a human being could perform. We had an example of this recently. We were labeling a certain type of image for a customer, It had to do with vehicles, and we found that we were getting eventually an 8% error rate. And we thought that this was a problem with the machine we were using until we went back to our labelers and the labeled captions that they were producing. And we found that a human being looking through the sample images with all the time in the world to label it and Google at their fingertips, we're still making an 8% error. And this is typically how a superhuman AI is defined. This example of artificial intelligence is one that I just want to step into briefly. And it's a type of machine that was invented fairly recently, sort of four years ago, and it's called a generational adversarial network. So the researcher that invented this, essentially what he did is he tried to create a neural network that could identify whether a piece of artwork was true or fake, whether it was original or fake. And what he found is that he actually didn't have enough training data on fake and real artwork. So he created a second neural network to generate art. And the idea was that it would, whatever it generated would be fake. So there was a massive fake training data set. And then whatever artwork that he fed in that was actually real artwork, this detector would be able to work out. And he found over time that the detector and the generator, if they were given little bits of information about each other, that they were actually able to get better and better at not only detecting whether a piece of art was fake or real, but also generating art. And the generator gradually became better and better to the point where the artwork being generated was phenomenally good, virtually indistinguishable to the human eye from real artwork. And he realized that the value of what he had created was not in the detector to detect whether art was real or fake. The value was in the generator. He had created a machine that could be trained in lockstep till the point where it could actually create artwork that was indistinguishable from real artwork. This is called a generational adversarial network. Adversarial because they fight against each other. And it's really driving a lot of the trends we're seeing in AI at the moment because it has the ability to create something, not just consume and detect something. So to give an example of what that looks like, these are all images that come from a site called thispersonisnotreal.com. It was created from a neural network that NVIDIA put together, and none of them are real. Now the level of detail is incredible on these images. They really look like real people. You can see there's very fine details in the eyes and in the hair. The glasses have been generated around the face with a brand logo on them. Really is quite stunning what these machines are doing. And of course, this is what gave rise to the deepfakes phenomenon, which we're seeing. So I guess for me, just another example of how any new and emerging technology, which is spectacular, which takes a leap forward instead of a step forward from the status quo, has its uses and has phenomenal uses, but always will be seen by the good actors and the bad actors as a way to progress. For me, this is exciting. The ability to do this kind of thing where we couldn't before, regardless of how much computational power we had, is really phenomenal. So that's just a little bit about AI and where it came from and some of the amazing steps that we're taking in generational adversarial networks. Superhuman AI, for example, translating better than a human can translate, generating Amazon quotes better than a human could, image recognition, which is an area we work in a lot, and the computers in a lot of areas now can produce phenomenal results on recognition. For example, computer vision can now look at a scan from a radiographer and produce better prediction of whether there's a tumor or an abnormality than an actual radiographer can. And I believe that this is a classic example of where AI and the advancements of AI can do real good, because they don't get tired, they don't fall asleep, they don't take 24-hour period breaks, they just keep processing. And if we can keep going on those trends, then it's going to be phenomenal. So that brings us to IoT. How does IoT and AI fit together? And what I've included in here is the idea behind AI and IoT working together that is the common conception and probably the most prevalent at the moment. And that's where you have traditional IoT. So let's say devices that are in the field and they're collecting information. They're collecting, how is this motor running? Is this fridge door open? Where is my electricity supply coming from? And bringing all of this noisy information into a centralized area to be processed and have predictive analytics or analysis done on it. And certainly we've made incredible leaps forward in this space. In the kind of traditional IoT and AI space, I think that the ability to predict when a motor is going to fail, or to predict when perhaps a health and safety incident is about to occur on a factory floor, is going to be one of the most amazing areas that evolves over the next little while. But that's sort of a more common use case. And what it really does depend on is cloud processing. So what we're looking at here is the mean time to train the ImageNet system. So one of the classic competitions they have every year is, can you recognize the images in a vast database of images? And you'll see over time, and this is a relatively short period of time, the time to train has decreased from 60 minutes down to 2 or 3. Now, the same thing is true for IoT. Whereas before, our devices would be living out in the wild and collecting lots of information on sunshine and how the factory is running and what the ambient noise is, and then sending them centrally, the models that we had to train in order to be able to understand those were quite big and bulky, and you looked at about a week's training time to get a good model out. Training a model for a week impacts how quickly you can innovate on that model. Because you train it for a week, you run it for a little bit, you find out that something's wrong, you train it for another week, but you're looking at month-long cycles in order to be able to improve those models. And in actual fact, what you want to do is cut those down to minutes or hours, because then you can innovate on the models and the depth and the accuracy that they can work. So certainly the cloud has helped a hell of a lot with that. You can now spin up specialized AI-based machines in any of the large cloud providers, and you can load your model, and they'll actually walk you through the process of training and testing the model, largely with drag and drop tools, actually. Most of the cloud providers give you drag and drop interfaces to create your models. So one of the other things that's really spurring this revolution in IoT and AI is the fact that 10 years ago, if you wanted to put a model together that would predict when a motor is going to fail, you actually had to be a true Python developer and a data scientist. And the cloud providers are now what they call democratizing that and bringing it to the fore. But there's a second trend that I want to spend a little bit more time focusing on. And we were having a conversation with a customer a little while ago. And this customer was talking about the concept of, 15, 20 years ago, we all worked on distributed architectures, so server-based architectures. I remember when I was a programmer, everything we did to try and make stateless parallel processing happen, because you had a server farm in your business with 5 servers and you had to get them to work together, and that was how you got the load off those servers. And when the cloud came along, and especially with the cloud, large-scale distribution of high-speed connectivity, everything moved into the cloud. I was working with a customer the other day who did actually have on-premises servers, and I said to them, I honestly can't remember the last time I worked with servers and virtual machines, because the cloud has taken over that whole journey. But this brings a special type of problem to IoT and AI, and that is that the size and amount of data that you're processing at the actual location, what they call on edge, has really just accelerated massively. So let's stick to the example of processing in computer vision. You don't want to stream 30 frames a second of 70 cameras in a warehouse all up into the cloud. Regardless of your connectivity, that is prohibitively expensive in terms of bandwidth and in terms, and really it's just, it's a bit of a waste, to be honest. So large parts of where IoT and AI are now starting to come to the fore is in what's called the edge evolution. So we had everything in servers that our cameras connected to. That was 20 years ago. Then we moved everything into the cloud. Now we're starting to not move everything, but move parts of that back out onto the edge in terms of AI. And I wanted to talk a little bit about embedded devices. So the bottom left, there is a picture of one of the very first Arduinos that came out. The Arduino is a software development platform that really tried to make accessible the idea of building small devices. I bought one of these very first ones, and my first Arduino was barely capable of running a couple of menu options and switching on a couple of LEDs, etc. Contrasting that with a device by ETA Solutions in the top right there. Now, this is quite a phenomenal device that they've just brought out. This device can process any deployed neural network, a TensorFlow neural network, for example, that you deploy onto the device itself. And it can process about 1 frame a second, and it runs with a CR2032 battery, essentially a watch battery, and it can run for months at a time. So just having a look at that, you know, the kind of the hardware progression in terms of what the edge devices can do and how they can progress, what they can process, sorry, is phenomenal. Thinking about a device that I could stick up on my wall that can process 1 frame a second of any type of neural network that I deployed to it, and send me alerts when it recognizes something in those frames, is mind-blowing. What's really great about that is it now starts to open up many use cases that before were not possible. So again, let's talk about cameras, because cameras are defined as IoT devices. If you had to stream every frame up into the cloud, you could do very rudimentary things with cameras. For example, a lot of the camera manufacturers are now embedding a face detection algorithm in the cameras, but it's not generic. If I want to sit in my office and train a neural network on how to recognize a white car when it drives past, I could never deploy that to the edge. I could never hope it would run at the edge. I would be streaming into a local server or up into the cloud all the time. Now, this kind of device makes that possible. Now we can think about things like a small low-cost device that watches the bird feeder and alerts when a rare bird arrives. We can think about having 20 of these devices dotted around our house and train them to recognize our dog or our cat when it walks past. And so it really starts unlocking a lot of different potential for use cases. And to me, this is really where AI and IoT are going to start playing, is in this combination of we can now train models so much quicker. It's not going to take us a week or an hour. I can train my new model in 20 minutes. So I can iterate massively in the cloud, but I can also then deploy that model down onto the edge and have the edge processing done there on small and, more importantly, low cost, low energy devices. And I think this is where one of the real trends in AI is going to be coming from. So what are we seeing that these trends in deploying models into the edge and actually starting to put a heavier reliance on AI and IoT, specifically computer vision, is driving? So here are 4 examples of projects that we've recently engaged in with a customer. On the far right, about 7 or 8 years ago, we dealt with a customer that wanted to monitor in their shop whether the fridge door is open. Which, right, it's a classic IoT example. What we've said to the customer is, instead of 8 devices for your 8 fridge doors, we can now put up a single camera. We can not only train it to recognize when the door is open or closed, but we will also do rudimentary stock counting for you. So we're starting to see the replacement of very small, specific embedded devices with generalized devices like computer vision and cameras. We're working with a customer now who wishes to count and detail every box that moves through their warehouse. And again, they've looked at RFID stickers, but that is a significant investment in hardware and time. We're working with them on the computer vision side to say, a couple of high-res cameras up in your factory, and we will be able to count the boxes, read the labels, and document where they're going. We've just recently dealt with a mining company that lowers rovers to the sea floor, and they suck up silt, which then gets sifted for various precious artifacts. And this particular rover, if they haul it off the floor and the cables get crossed, it causes them a lot of damage. Now, again, they are evaluating what I'm going to call traditional IoT devices, so magnetic sensors on the cables that test them, tension sensors. But what we've proposed to them is computer vision, where cameras just watch the cables and alert when they cross. And the advantage of that is we can then use those cameras for other things, such as, you know, what is the weather like as it lifts? Is the sea chop quite high? Have the cameras themselves been moved out of alignment? Is somebody in the frame that's not supposed to be there? So really, we're seeing a lot of use cases come to the fore with this combination of large-scale cloud processing for better and better models and being able to deploy these generalized items onto the edge. And there's a whole different aspect that I want to bring in terms of IoT and edge processing, and that is cameras themselves. So cameras have gone through massive maturity curves. The very first camera that I had in a cell phone, I remember going, isn't this incredible that we can put digital cameras in a cell phone? And I actually looked at the image the other day. It's a terrible, grainy image. To the point now where we're starting to use cameras for various uses that actually would not have been possible before. So this is a bit of a video from Tesla's AI Day, where they talk about the vision model that they use on their self-driving cars. And I'm just going to fast forward to the relevant point here, because I want to show one particular aspect of it. So just to put it into perspective, what they're talking about here is the capability of using 2 cameras and using binocular vision from the two cameras to put together a full vectored view. I'm just going to fast forward to the point where they show how that works. So essentially what they do here is they have 8 cameras around the car, and they take the computer input from all 8 cameras, but then they merge them into one neural network that is a 3-dimensional neural network. So what they're ending up with is a 3D view of the place that you're driving, the space that you're driving in, but taken and merged from 8 cameras. What's really quite phenomenal about that is the fact that, so here's the view that it creates in 3D. And what's amazing is that this is something that is surpassed what is being done in nature. In nature, we have 2 visual systems, binocular vision, that gets combined. Spiders have significantly more eyes. They do this kind of thing all the time, but we're getting machines to do this based on a visual system. And that's really quite a phenomenal achievement. So where is it going? We also need to talk about the most prevalent IoT edge device that is out there, and that is your mobile phone. Now, mobile phones have come leaps and bounds. In a lot of ways, mobile phones have driven the AI revolution. And I'll explain that in a second again by referring back to the use of the cameras. If we look at modern mobile devices, modern phones, such as the latest Samsung or iPhones, they embed a fair portion of their chips is in AI processing. So they have dedicated cores that just execute artificial intelligence models. Now, if you take the camera on a modern Samsung phone or a modern Apple phone, and you compare the quality of the image to what that was taken 5 years ago, it really is phenomenal how well those images come out. But about 80% of that is not down to the physical hardware itself. It's down to the artificial intelligence processing. The AI models on a modern phone are doing so many levels of processing, from high dynamic range to edge outlining. The modern phones will even detect the type of image you're taking. So in the middle there, you can see there's a sunset image. And if it falls into one of a certain number of categories, like portrait, landscape, sunrise, sunset, human area, visual, it actually applies specific neural networks to those, as well as all the pre-processing and post-processing that has happened. So what has happened with these devices is that gradually, and without us looking, the AI, the neural networks and AI that they're driving has become just an ordinary part of everything we do. You take out your phone, you take a picture, you send it to your friend, you move on. And in the background, the AI is really driving that entire experience. You talk to your phone and you ask it to do stuff for you. Your planner that tells you when you're going to have collisions in your diary. All of these things are being driven by AI. Even face recognition, which went through a great hype cycle through the traffic disillusionment. While everyone was getting concerned about face recognition in public spaces with cameras that track your every move, it became such an embedded part of these devices. Because it was so convenient, we adopted it wholeheartedly. And for me, this is a great way of looking at the trend of AI. It's something new and fancy, and so we become excited about it, but we also get scared about the bad actors that can play here. And while we're busy grappling with those problems, gradually it just starts solving more and more problems and bringing more and more convenience into our lives until we look back and we couldn't do without it. One of the classic examples I thought of AI and artificial intelligence. So this is the video clip of Arnold Schwarzenegger in the Terminator 2. And I remember watching this classic scene when it first came out and thinking that I was a programmer at the time and thinking that's impossible. There is no way that kind of thing can be implemented. And that's the scene over here. So he's walking around looking at visual objects and essentially breaking them down into what they are. Now, about 6 or 7 years ago, I gave a talk where I said, this used to be science fiction, and now it's possible. We can absolutely build models. In fact, the self-driving cars use these models all the time that detect what something is, highlight it, look it up, and annotate it. But what to me is even more scary is that this used to be possible 3-4 years ago with our most modern neural networks, and now it's possible in an IoT device. You can take a small, low-cost, low-powered device and build these kind of models into it. And suddenly that opens up a lot of different use cases. So I'm going to take a little bit of a sidestep there because no talk about AI and IoT, specifically cameras and computer vision, would be complete without talking about the ethics of AI. So the ethics of AI gets broken down into 3 sections. Machine ethics, which is really the ethics of, excuse me, the machines themselves. Can a machine decide? The classic example there, if a car is hurtling down the road and there are two paths it can take, and one path there are a bunch of school children running across the road, and the other path there are a bunch of adults running across the road. Which road should that machine decide? It has to make a decision. Which road should it take? And really the crux of the problem here is that one of the biggest crowdsourced ethical experiments was that exact experiment. They presented several use cases to human beings and asked them what decision they would make. And the end result of that research was actually it varied so much from human being to human being, from region to region, from gender to gender, from race to race, that there isn't actually a definition of of ethics and how it should work. So we're grappling with something that we have no definition of, and we're trying to program it into our machines. The second area we need to talk about, obviously, is roboethics. So that's the ethics of the people creating the machines. This is very often what we talk about when we say ethics. Fantastic that face recognition can unlock my phone for me, but who's using it out there in the wild for nefarious reasons? And then obviously ethical computer use, which is how do we use these tools ethically? I want to take a very small subset of this and talk about it, which is privacy. So I run through a little thought experiment usually when I talk about computer vision and privacy, and I go, imagine you're at a soccer field, you're walking around, someone runs up and snatches your backpack and runs away, right? You happen to notice that there was a security guard standing at the far end of the field. You go to him and you say, did you see who took my bag? And he said, yes. Gives you a description of the person, and you're able to go to the cops and you say, this is the person that stole my bag. Hopefully they catch them. Now that was a person in a public area observing you. Imagine you were in the same situation where you walk onto the field, someone runs past, they grab your bag, they run away, and you see that there's cameras up there. The cameras now are much better because human memory is fallible. So perhaps the guard didn't quite see, or he wasn't paying attention. Cameras were watching the whole time. So now you're really glad that those cameras were up there. But now what if somebody said to you, those cameras, by the way, are performing face recognition. They can recognize you and know where you are at every point in that field. They know where your child is. Most people start getting a little bit uncomfortable at this point. You know, why are they performing this? If we take it a step further and we say, those cameras can tell things about you and take action. They can alert someone when you've arrived at the field. They can recognize you and specifically you. They can tell your age, your gender. They can tell when you're happy, when you're not happy. They could, in theory, tell when the match is going well by scanning the expressions of the crowd and when the match is not going well by scanning the expressions of the crowd. Most people now start to get a little bit uncomfortable and go, that feels like a violation of privacy. Until we take it right back to the beginning and we say, those cameras are performing only in exactly the role that the security guard did right at the back of the field. That security guard can see the expressions on people. He can see when the match is going well or not going well, and he can take action based on it. But when a new technology comes along, we tend to try to hold it to a much higher standard. And so it's an extremely difficult issue to work with, because the idea that the cameras are doing something that any human being in any public space could do is no longer justification for the fact that they can do it. What it really comes down to is, what action can they take? If that security guard could take an action like call his friend and say the match is going well, that's great. But if he could take an action like call a whole bunch of other security guards and have to clear the field out, we would be a bit unhappy. And that's where the privacy and ethics discussion comes down to as well. If those cameras can monitor the crowd, that's fine. But if they're feeding that information to someone who doesn't have permission to use it, or they can take action based on that, that is not a supported or opt-in or volunteered for action, that's when we start crossing the line. And the thing about AI and IoT is that it allows that line to get thinner and finer every day. So privacy is a thing that we absolutely and actively have to pay attention to all of the time. But just to kind of take a conclusion around the whistle-stop tour that we've had of AI and IoT. AI and IoT is characterized, I think, by 5 large emerging trends that we're seeing. We're seeing bigger and better models because cloud training is so much easier and cheaper to do. So the world-class leading computer vision models of 10 years ago had an order of magnitude less neurons than the models we have today, and therefore models we have today are more accurate, faster, better, etc. We're seeing smaller and faster edge computing, lower power. We're seeing the ability for them to execute faster. We're seeing the ability for them to live anywhere and be deployed easier. We're also seeing more generalized. At the moment, you can go into your local hardware store, buy a camera, and probably it'll have a dedicated face detection algorithm, maybe even a human detection algorithm. But if you want to train your own model to find a certain type of bird and deploy it to that camera, at this point, that's not possible. We're starting to see the emerging trend now of general purpose definition models that can be deployed to edge devices and cameras. The privacy issue is only going to get bigger. It's only going to need more focus. And it's unfortunately only an issue that is going to be solved by constant and vigilant work to make sure that we don't overstep those bounds. It is subversively easy to work on a technology, get caught up in it, and cross a boundary. And so privacy advocates, privacy groups, certainly the large cloud providers have a pivotal role to play here in making sure that when we use this tech for good, we're also actively, constantly focusing on making sure we don't cross ethical and privacy boundaries. And then the last trend is seeing IoT, or seeing your devices as IoT sensors. Your phone, your fitness device, they are becoming not only the most powerful, but the most prevalent of IoT devices. And not only that, most of them these days have dedicated AI chips on them. And this enables a whole host of use cases, most of which I think we've only just started scratching the surface on. So that's everything I've prepared. That was, for me, just a take on AI and IoT, the emerging trends that we're seeing in the market at the moment, what's bubbling to the fore. And really, for me, I'm excited about it. I'm excited to see those use cases that we haven't even thought of yet coming to fruition and being possible and making our lives easier because of prevalent, ubiquitous, low-cost AI. And I'm really excited to see how that can make a big impact on our lives. So thank you very much. I'm Peter Reid, and it's been my pleasure to be with you for this half an hour.
Thank you, Peter, for that very insightful presentation. Certainly learned a lot today sitting through this session. Thank you for giving up your time and sharing some of your knowledge and expertise with us on this platform. To everybody else, please remember to log on to the next link at the conference, the Connect Conference 2021. Thank you so much. Goodbye.
Ladies and gentlemen, we trust you enjoyed the session. Thank you to all our sponsors and partners for helping us bring this event to you. Please click on the next link to join the following session.